video will cover simplified algebraic expressions, which is part of the lesson of Friday, November 13. So if you are in third period or fourth period and you're not in class, you should be watching this video. Or if you are in fifth or sixth and you were absent on Thursday, November 12th, you should watch this video. You do need to complete the notes, and you will also be responsible for the homework. So let's get started. We're going to start by writing some definitions, and then I know that some of you might feel like this is a little repetitive from Algebra 1, but it doesn't hurt for you to review. So please just bear with me, pay attention. I am sure that you will learn a few things, so you will refresh your mind on some concepts. So first we're going to define what is a term. And a term is a number or the product of a number and variables. And those numbers and variables could be raised to powers. So they could be with an exponent of 1, 2, 3, and so on. So when we read the word product, what operation does that imply? The product of something is what? Addition, subtraction, multiplication? Multiplication. Multiplication, very good. So what we're saying here is that this will be, it could be some numbers, letters multiplying, right? So that is what we will consider a term. Now let's move on to numerical coefficients. So the numerical coefficient of a term is the numerical factor of that term. And so every term will have a numerical coefficient. That's what we're going to do here on example 1, find the numerical coefficient. So I want you to write in parentheses that the numerical coefficient will refer to the big number. So let's go to example 1, and we have a total of 5 terms. So on the first one, the numerical coefficient will be -3. Now, Samantha, can you tell me the numerical coefficient of the next one? 22. Yes, 22. Mr. Jordan, next one?
1.
1, very good. So if you do not see a number, remember, there's an implied 1. Destiny? -1. -1, very nice. We have a negative sign, and so that will be a -1. And Mr. Hay?
1/7.
1/7, very good. So this expression x over 7, it is equivalent to 1/7 times x. Remember, those two are equivalent. So now let's move on to what are like terms. And I know that you've heard that expression before, so let's just write the definition. Like terms are terms with the same variables. And those variables are raised to exactly the same powers. So if you have your highlighter available, please, I want you to highlight the following: exactly same powers and same variables. So we could have x to the 4th power and x to the 6th power, and so those, because they don't have exactly the same power, they are not like terms. And we do have a word for terms that are not like terms. We call them unlike terms. And in fact, that is part of the definition. So unlike terms are terms that are not like terms. Just like the negation of like terms. So we have 4 different sets, and we need to determine if they are like or unlike. So for the first one, Destiny, will those be like or unlike? Unlike. Very good. And so they are unlike because even though they both have the same variable x, one is x to the first power, and the other one is x to the second power. Samantha, next one. Like, very good. And so they all have different coefficients. However, all 3 of them have x squared, and x squared, and all 3 of them have y to the first, y to the first, and y to the first. So they are like terms. Now, Mr. Hay?
This one's unlike.
Well, I know that you got the tricky question here. So if we look at the definition, it doesn't really say anything about the order. So as long as they have the same variables and the same powers, they will be like. And also because for this type of multiplication, we say it is commutative. So the order of the factors does not change the product. Yes. Oh, thank you. Okay, next one we have Mr. Jordan. Same variable, yes. Same power. So we say like. Okay. So x to the 4th and x to the 4th, they have opposite coefficients, but still they have same variable, same power. So let's go to the next slide. Now, let's write some statement here. So simplifying the sum or difference of like terms is called combining like terms. So remember when we say sum or difference, we're referring to adding or subtracting, right? So we're going to refer to that process. We're going to summarize it into one by saying combine like terms or combining like terms. So I'm going to do example 3, and then you guys will do example 4. Okay? So what we do here is we are going to add coefficients. But let's not forget, for example, here I can't just say the answer is 7 minus 3, which will be 4. What am I missing there? X, right? So I still need to consider that we're multiplying that 4 by x, all right? The second one, they are like terms, so we have 10y squared plus 1y squared, and so that will be 11y squared. The next one, the only 2 that are like terms are the 2x and the negative 3x. So we're still going to have 8x squared, however, just by itself. And then we combine the like terms that I have circled, and that will be negative x. For part D, we have all 3 terms are like terms because they have n to the second power. So what I like to do is combine the ones that are positive. So 9n squared plus 1n squared, that is 10n squared. And then we subtract 5n squared, so that will be 5n squared. Remember I did this, 10n squared minus 5n squared. And that's how I got my answer here. Okay, now to combine like terms, and this might sound a little weird at first, but then we will explain it in a minute. So to combine like terms, we're going to do the same thing I did. We add or subtract the numerical coefficients. Now here I'm only using the word add because remember subtraction is the same as addition, it's just with negative numbers. So we add the numerical coefficients and we multiply the result by the common variable. Just like I did with the first example, when I asked you if I add 7 plus -3, I get 4, right? But it's not only 4, we still need to consider to multiply it by that variable that they both have in common, which is x, right? So that's why it sounds a little confusing, multiply. But that is just to remind you that you cannot forget the variables that go with the coefficient. So now I'm going to pause the video. I'm going to give you some time for you to work on example 4, and then we will come back and review the answers. So let's review your answers for example 4. And the first one, part A, we're going to combine the two that contain x. So 2x plus 3x is 5x. And then 5 plus 2 is equal to 7. The next one, we're going to combine -5a plus a. So that will be -4a. And then the numerical parts, the constant terms, so -3 plus 2, that is -1. Now for the next one, they will stay the same because they are unlike terms. However, what I want you to do is to write down the one that contains y squared first. And the reason for that is we call this writing in descending order. I want you guys to get used to it because that's how we're going to write down polynomials, which is what we're going to be working with next. We'll start with quadratics, and then next semester in January we'll move on to polynomials of higher degree. So when I say descending order, I mean you start with the highest exponent, which will have the highest degree. That one is of degree 2, and the next one is of degree 1. All right. So the next one, we combine the two that contain x. 2.3x plus 5x is 7.3x minus 6. And the very last one, what I'm going to do is convert to the same denominator. So plus b is equivalent to 2/2 times b. And if we combine the coefficients, we will have 2 halves minus 1 half. And so that is equal to positive 1/2 times b. So remember, one is positive, the other one is negative. So let's go to the next and last slide for this video. And what we're going to do here is use the distributive property to remove parentheses. And remember, parentheses, they imply multiplication. And when we say distributed number, we imply that you need to multiply, in this case, multiply that number to both elements inside the parentheses. So the long story here is that you multiply 2 times 3x, I'm sorry, not 2, but 5 times 3x plus 5 times 2. And the result for that will be 15x plus 10. And I know that some of you feel very comfortable doing this process in your head. However, if you're not so sure, it doesn't hurt to write it down. For the next one, we have -2. So we're going to distribute that -2. We'll have -2 times y minus 2 times 0.3z minus 2 times -1. And this is where you need to be very careful when you have a negative sign and then another negative sign. So to answer this question, we'll have -2 times y, that is -2y. -2 times 0.3z, that will be -0.6z. And -2 times -1 will become +2 because we have a negative times a negative. And the third one here, we have a negative sign outside the parentheses, and remember that negative by itself implies that there is a -1 multiplying. And so if we distribute that -1 to every single term inside the parentheses, we will be multiplying every term by -1, which will cause to change the sign to its opposite sign. So the shortcut for this will be, if you have positive 9x, you will have -9x. If you have positive y, you will have -y. If you have -2z, you will have positive 2z. If you have positive 6, you will have -6. So now I'm going to pause the video, and I'm going to ask you to work on the next 3, and then we will come back to check our answer. Okay, so we're going to review example 6, and notice how it says here, simplify each expression. So what you need to do is distribute and combine like terms. So for the first one, we will distribute the 3, but only to the 2x and the -5. So that will be 3 times 2x is 6x. 3 times -5 is -15. And we still have a plus 1. So now combine like terms, we will have 6x minus 14. Part B, we distribute the -2 only to the first terms inside the parentheses, the first 2, and that will be -2 times 4x is -4x, -8x. -2 times 7 is -14. And here, let's not forget that the negative sign implies there's a -1 here. So -1 times 3x, that will be -3x. And -1 times -1, that will be positive 1. Now we combine like terms, so -8x minus 3x, that is -11x. And -14 plus 1 is -13. And the last one, be careful and do not, I know you will be tempted to add 9 plus 3. The reason you cannot do that is because multiplication must be done before addition. So this will be 9 plus, and then you distribute the 3. So it will be 3 times 4x, that will be 12x. And then 3 times -10, so that will be -30. Now after we multiply, we go ahead and combine like terms, which is the case with 9 minus 30. And so that will be -27. No, I'm sorry, -21. -21 plus 12x. And if we want to write it in descending order, remember the highest power first. It will be positive 12x minus 21. So the degree of the first term, the 12x, that will be degree 1 because the x doesn't have an exponent, so we know there's an implied 1. Plus u, what will be the degree of 21, -21? 0, very good. So you can imagine there's an x to the power 0 here. So any constant term is of degree 0. So this is the end of the video.